Your notes for today are on adding and subtracting radicals. So to start off, I want you guys to think about if I ask you to add, let's say, or subtract rather, 3x minus 4x. You're allowed to do that because they're like terms. They both have x's. Same variable with same exponent. And so you all know that that equals negative x. You just subtract 3 minus 4, keep your x. Well, the same concept applies for radicals. If I asked you to subtract 3 square root of 6 minus 4 square root of 6, you can do that because they both have the same radical, the same index with the same radicand, square root of 6 and square root of 6. So imagine you have 3 square root of 6 minus 4 square root of 6. Well, now you have negative square root of 6. It's the same concept as adding and subtracting like terms. And so your final answer is negative square root of 6. Okay? So, in order to add or subtract radicals, you have to have two things. First, the same index, and second, the same radicand. Okay, same index and same radicand. That's like what we have here. Same index, your index is 2 because it's a square root, and the same radicand, your radicand is 6. So same index, same radicand. Okay, that's how you add and subtract radicals. So what we're going to do now is we're basically going to go through a bunch of examples. Some of them are kind of nasty, so here we go. First example is the one that we just did. 3 square root of 6 minus 4 square root of 6. This should be easy for you guys. Same radicand, same index. 3 minus 4 is negative 1, so negative square root of 6. Done. Our second example is a little bit more complicated. Negative 2 square root 3 plus 3 square root 27. When you look at this at first, you might think that you can't add these together because they don't have the same radicand. This is square root 3 and this is square root 27. But what can you do with this square root 27? Well, you can factor tree it. So that's what I'm going to do. 27, factor tree, 9 times 3, 3 times 3. Here are my primes. Because it's a square root, I'm looking for pairs. So I'm going to circle this pair. Out comes a 3, and a 3 stays in. Now remember that there's already a 3 here. So this 3 that comes out and this 3 that stays in are going to multiply together. So I end up with negative 2 square root 3 plus 9 square root 3. Okay, this one's left over here. Right, this is left over. So now they have the same index and the same radicand. They're like terms, I can add them together. Negative 2 plus 9, 7. So 7 square root 3. And that's your final answer. I hope nobody has a question because you can't ask me. Next one, negative 3 square root 18 plus 3 square root 8 minus square root 24. So again, these all have different radicands. Even though the index is the same, it's all square root, square root, square root, you can't add them together. So we need to factor tree. I'm going to start with my 18. 9 times 2, 3 times 3. Here are my primes. Because this is a square root, I'm going to look for my pairs. So here's a pair. The 3 will come outside and multiply with this 3 that's already there. And I'll end up with negative 9 square root 2. Same thing with the 8. I'm going to factor tree. 8 is 4 times 2. 4 is 2 times 2. Here are my primes. Because we're doing a square root, I'm looking for pairs. This 2 comes outside and this other 2 stays inside. Because there's already a 3 outside, this 2 that we're taking out is going to multiply with the 3 that's already outside. So we'll have 6 square root of 2. Okay, the other 2 is what's left over. This 2 here. This one. All right, next, the 24, factor tree. This is 8 times 3. This is 4 times 2. 2 times 2. Here are my primes. And again, square root, so we're looking for pairs. Here's a pair of 2's. The 2 is going to come outside, and the other 2 and 3 will stay inside. So we end up with minus 2 square root 6. Now still, we don't have all the same radicands. That's okay, we can't simplify anymore, so that just means that the ones that we can combine together are these two terms, because they both have square root 2's. When I combine them together, I get negative 9 plus 6 is negative 3. So negative 3 square root 2 minus 2 square root 6. Final answer. Next problem. Negative 3 square root 5 minus square root 6 minus square root 5. Now this one's a little bit easier than the one that we just did because they're already simplified. Square root 6 is just 2 times 3. There's nothing we can take outside, so it just stays like that. The terms that we can combine together are negative 3 square root 5 and negative 5 or negative square root 5. Same radicand, same index. They can be combined together. So we get negative 3 minus 1, negative 4 square root 5, and then minus square root 6. That's your final answer. Next, this one's a little bit more complicated. Now there's a couple of ways that you can do this problem. I'm going to start out by rationalizing the denominator. You can do it in other ways and then rationalize at the end, and that's fine if you choose to do it that way. So I'm going to start out by saying this is square root 32 over square root 3, and then plus square root 2 over square root 3. Now I know that we're doing a square root, so in order to complete that square, I need how many more 3's underneath? I need one more 3, so I have to multiply by square root of 3 over square root 3. Same thing happens here. Square root 3 over square root 3. I end up with, a little error up here, I end up with square root of 96 divided by 3. 3 times 32 is 96. And then plus square root 6 over 3. Now we're adding fractions. We have our common denominator. The numerator I'm going to try and simplify. I'm going to take my 96 and I'm going to factor tree it. So this I know is 32 times 3, which is 8 times 4, 2 times 2, 4 times 2, 2 times 2. So here are my primes, 2, 2, 2, 2, 2, and 3. We have a square root, so I'm looking for groups of 2. So here's a group of 2, here's another group of 2, and I'm left with a single 2 here and a single 3 here. So out comes a 2 from this and a 2 from this. That means that I now have 4 square root 6, the 2 times the 3 gave me 6, and the 2 from here times the 2 from here gave me the 4, plus square root 6 all over 3. My common denominator was 3. So now, same radicand, same index, 4 plus 1 is 5. So I get 5 square root 6 over 3. And that's your final answer. Alright, another one that's kind of messy. 2 cube root 9 plus cube root 81 minus 2 cube root of 1/3. So I'm going to start out by rationalizing my denominator here on the last term. So I'm going to multiply the numerator by So I'm going to multiply the numerator by cube root of 3 times 3. Give me like 5 minutes. And the denominator by cube root of 3 times 3. Because to complete the cube, you guys want to be my students?
Yeah.
Come on in. To complete the cube, we need 3 times 3 times 3.
Yeah.
Right? You guys are part of the recording that we're going to send out tomorrow.
Hey guys.
All right, so over here, my 9. 9 is just 3 times 3. This is a cube root, right? So we
you
can't.
need one more 3.
Well, to rationalize a denominator, you need one more 3, but we're not rationalizing the denominator. I'm just seeing if I can simplify. So that stays the same. 2 cube root 9 plus my 81. How can I factor that?
9 times 9. So then
Okay.
there's 4 3s.
3 times 3,
And then
and then 3 times 3. Now we're
So
taking the cube root.
So,
So
there's
here are my primes. Hang on a second,
Oh.
we're explaining so we want to be clear. So we got 3 times 3 times 3 times 3. We're taking a cube root. So you're looking for groups of how many numbers?
3.
3. So here's a group. What comes outside?
1 3.
Mhm.
And
So we'll
then
get 3.
and then 1 3 stays on the inside.
Good, this 3 stays inside. Okay, now our last term, we rationalized the denominator. So the numerator, we've got minus 2 times what in the numerator?
Times cube root 3, or is that another 3 on top?
Cube root 3 times 3.
Oh, so then it's cube root 9
Cube root 9. Okay, so cube root of 9
over 3.
over 3. Good. Over 3. All over 3. Yeah. Okay, so now here's our problem. In order to add and subtract, we need to have the same index and the same radicand. So our first term has a cube root 9 and our last term is cube root 9. The middle term is cube root 3, so we can't combine those. The ones that we can combine,
The first and the last one.
right, are the first and the last. Good. So now it's a matter of adding 2 and negative 2/3. So I'm going to do a little side problem here on the bottom. 2 minus 2/3. How do we add fractions?
You have to have a common denominator.
Good, common denominator. So I'm going to put a 1 under here, multiply by 3 and 3. So I get 6 minus 2. 6 over 3 minus 2 over 3, what's that?
4 thirds.
4 thirds, good. So that means my first and my last term combined together to be 4 thirds.
Cube root 9.
Cube root 9, good. And then plus the middle term. 3 cube root 3. And this is your final answer. That was a hard one. Okay. The next one, we've got like 3 more examples to go through. So this is negative 4 times square root 6 times 3 square root 2 minus 5 square root 3, close parentheses, plus 5 square root 48. So let's start out here by distributing inside the parentheses. What do we get when we distribute and we multiply? Negative 4 square root 6 by 3 square root 2.
Negative 12 square root 12.
Good. Multiply the outside numbers and the inside numbers. They have the same index, so we can multiply them together. So you guys said negative 12 square root 12. Now same for the second term.
Positive 20 square root 18.
Good. Positive 20 square root 18. Negative 4 times negative 5 and square root 6 times square root 3.
And plus 5 and square root 48.
Good. So
when
right
you-
now, can we add any of these together?
No, because
Why
they don't
not?
have they have the same radicands, but they don't. I mean, they have the
They don't
same
index, but not the
radicals. But
Good.
don't
They have the same index, but they don't have the same radicand. So we're going to factor tree.
Wait, so for adding, you have to have the same index and radicand.
Right.
Okay.
So 4 times 3, 2 times 2. Here are my primes. Prime, prime, prime. Square root. So we're looking for groups of how many?
2.
2. So there's a group. Out comes a 2. In stays
A 3.
a 3. Good. Since there's a negative 12 already outside,
Negative 24.
good. It becomes negative 24. Square root 3. Excellent. All right, the next one. 18. Go 9 times 2, 3 times 3. Here's my primes. Prime, prime, prime. Square root, so we're looking for groups of how many?
2.
Okay, so I'm going to circle the 3's. Out comes a 3, in stays the other 2.
60 square root 2.
Good, 60 because we already have a 20 outside. So 60 square root 2. And our last one, square root 48. 12 times 4. 4 times 3. 2 times 2. Here are my primes. Oh wait, I
2
forgot
times
that
2.
one. 2 times 2. There we go. Alright, so this was 2 times 2. And so these are my primes here. Okay, now we're doing a square root, so we want groups of how many?
2.
So here's a group of 2, here's a group of 2. What comes outside?
4.
Why
Yes.
4?
1, 2, and 1, 2. 2 times
And are
2
you
is
adding the
4.
2's or you're multiplying them?
Multiplying.
Multiplying, good.
So 2 times 2 equals 4, and then 4 times 5 equals 20, and then a square root 3 is left on the outside.
Good. And there's our square root 3. Okay, now I'm going to look and see, do I have any terms that I can add together?
Yes.
Okay, which ones am I allowed to add?
The
The first
and
and
the last.
Good.
Because
First,
they have the same index and radicand.
good. Square root 3, square root 3. This is square root 2, even though it has the same index, doesn't have the same radicand, so we can't add them. So negative 24 plus 20.
Negative 4 square root 3.
Good. Negative 4 square root 3, and then plus our middle term, 60 square root 2. And there's our final answer. Alrighty, next one. There's a couple ways you can work this one out also. Some are easier than others, so we're going to do the easiest way. All of them will lead you to the right answer unless you do something wrong. So, both of these are being divided by square root 8. So that means I can break it up. I can say 3 square root 40 divided by square root 8. plus 2 square root 24 divided by square root 8. And then minus our square root 5. Now remember back to our adding and, our multiplying and dividing radicals. If they have the same index, I can squish them together to one radical and divide. So 40 divided by 8
is
becomes
5. So 3 square root
3 square root 5, good.
plus
And then
2 square root 3 because 24 divided by 8.
good, and minus square root 5.
Okay. And now you can add the first and the last because it's the same index and radical.
Good, we can add these together.
Yeah.
3 root 5 minus root 5 gives
2
you
root 5
2
because
root
it's
5.
like a negative 1.
Exactly, 3 minus 1. So 2 square root 5 and then plus our middle term, 2 square root 3. And that's your final answer. You can't go any further because this is a square root 5 and that's a square root 3. Next one, we've got some variables now. So square root 12x to the 5th minus x, square root 3x cubed plus 5x squared, square root 3x. Can we add these together?
No.
No. They have different numbers under the radical. So let's factor tree. 12. 4 and 3, good. And then 2 and 2. And the x's, x times x times x times x times x, right? Since we're doing a square root,
You want groups of 2.
good, we want groups of 2. These are my primes. So you guys said circle groups of 2, so there's a group. What's another group?
There's x and x and x and x.
Right. Yeah. So out come how many x's?
X squared.
2, right? And out comes 1, 2.
So
So we end up with
2x squared, and then root 3x.
right. 3 is our prime that's left over, and x is our variable that's left over. So there's our first term. The second term, this becomes, let's do a different color. 3 is just 3, right? X cubed, x times x times x. What can we take outside here?
2 x's. So 1x was like.
There's our pair. We're going to pull an x outside. There's already an x here, so when we take this x out, we multiply it by this one,
So
becomes
it's
x squared.
negative x squared square root 3x.
Very good. All right, last but not least, can we do anything to our last radical?
No.
So we get 5x squared square root 3x.
So you can combine all of them.
So all of them can be combined, and this one's kind of tricky, but it's nice that these all worked out to be x squareds. 2x squared minus x squared plus 5x squared. What's that?
2x squared. It's. Oh, hey, hold on. 1x squared, and then it's 6x squared.
Yeah.
6x squared, right? 2x squared minus x squared is 1x squared, plus 5x squared is 6x squared, times 3 square root 3x. There's your final answer.
Okay.
All right, last one. So we've got square root 6y minus square root 3y over square root 2. So first thing I'm going to do here, and there's lots of different ways you can do this problem, the first thing I'm going to do is rationalize my denominator.
Okay.
Okay? So how do I do that?
You multiply both the top and the bottom by square root 2.
Good. Why? Why do you multiply the top and the bottom by square
Because
root 2?
that's just like multiplying by 1,
Uh-huh.
and that gets rid of the 2. So
Good.
it's not a square.
This is our clever form of 1. And to complete this square here, we're looking for groups of 2, so I want 2 2's. So this becomes 2 square root 6y minus square root
6y. And
Over.
then over 2.
Over 2. Good. Now we're adding fractions here.
it's
So we need a,
2 on the you need a common denominator.
good, we need a common denominator. I'm going to put a 1 under here, and what do I have to multiply the numerator and denominator by?
2.
Good, times 2 times 2.
So it's 2 square root 6y over 2 minus square root 6y over 2. So the final answer is 6y over 2.
Square root 6y over 2. Good. So we have common denominator, 2 minus 1 is 1. So this just becomes 1 square root 6y over 2. Or you can write it just square root 6y over 2. And that's your final answer. Okay. Good luck. Look online for your homework assignment.